welcome back to another video in the CCNP Advanced Routing course. So, this is video 2.4, where we go through the basic configuration of EIGRP. Now, we will only be going through the classic mode configuration, and that is because Packet Tracer does not support the named mode. So, we might have to put a little bit of pressure on Cisco Netacad to update the configuration options within Packet Tracer. But until that happens, we'll just do classic mode. I have I'll return to do the name mode when I have the equipment on hand to capture. But for today, in this video, we'll just do classic mode. So, logged into router 2, global config, and it's really complex to configure EIGRP. We give it an AS number. We'll go 100, just like in the presentations. And as we said, you can do the router ID like we do with OSPF. We'll go through it, and because we're on router 2, we'll do the quad 2s. Alright, and network statements. Now, these rules of thumbs for each network you have configured, directly connected, you would have a network statement. Now, for ease, I'll just do that, and subnet mask is /24. So that's as complex as it gets. And the other one is 23. Now, if you actually wanted to, you could go, well, if I put those two addresses into binary and look at the common bits, I would come up with something along the lines of a subnet mask of around 255.255.224. So you just break out 12 and 23. So what's common? Well, I'll let you do the binary breakdown. But that's how you do route summaries. You lay out the binary of the addresses you have that you want to summarize, find the longest common match, and you make that your new subnet mask. Alright, so we've configured EIGRP on router 2. So to confirm that, we can use the show IP EIGRP interface command, and this will go through and tell us all about the interfaces that are now running this protocol. So we can see here that we have it running process 100 and the interfaces that it's now active on. Now, there's no peers because we haven't configured it anywhere else. Over the router 3, and go in the global config. And no, I didn't do a full base config on each of these. I only did a fairly basic one. Got the interfaces up and running, and put remote passwords for remote login, but consoles and secret I didn't do, just for ease. Okay, so rule of thumb, we have 2 network statements to put in. So again, router EIGRP 100, network 10.0.23.0.255.255.255.255.0. Boom, adjacency. Found the neighbor and started doing the adjacency work. Alright, so next network is network 172.16.13, and I'm going to hazard a guess here, 0 and /24, because we kept it simple. And we also have a loopback address on here. So the network address for the loopback, just scoot this out of the way so I can see it, is 192.168.3.0. Now, there you have it. So, again, we can exit and do that show IPEIGRP interface. Scoot this over so we can see it all neatly. You'll see that G00 is active and it's formed a peer, so it's found an adjacency or a neighbor. Alright, and rinse and repeat for the others. Now I'll just hit pause, or should I just do it? That won't take long. Let's just work our way through it. Let's face it, you can always skip the time skip in the video if that is what you wish to do. So this one, again, I'll scoot this over to the side so we can see the networks that we've got to do. Router EIGRP 100, and what are we going to configure? Network. Now the other way we can do this is point 2 and do that. And you're going, what? Well, that's a explicit network statement. We talked about that in the presentations, and there we have the next one. Now, if you do a show run and look at your router statements, you'll see something. It's not what I typed, is it? Now, I did state in the presentations that the network statements should be a wildcard mask, which is the inverse of the subnet. Now, most operating systems for a long time have been doing the automatic conversion of that for you. So if you don't want to calculate it, you can just do the masking and it'll add the appropriate commands. Alright, so just wanted to show you, yes, I am typing in the actual subnet mask, but officially you should be using a wildcard mask, but just wanted to highlight the fact that the device will do the conversion for you, unless you're on a very, very old operating system. Router 1. Wow. So again, what do we want to do? We want to do the router EIGRP 100, and we want to have a couple of network statements here. We have the 10.0.12.0/24, and then we have the 172.16.1.0. And we have 192.168.1.0. Now, we have a little issue because of the way I configured my distribution switch, which I've just realized what I've done. So, can you see an issue? 172.16.1, 172.16.1. So this and this is the same network, but I've got 0.1 there, 0.2 there, and I'm guessing I've got 0.1 here, because that's the way we roll. So if we do a show run here, scroll down, and there's our 1.1 native 1.1. Might have a bit of an issue in here. What do you think? I've got a feeling I've put a 0.1 in there. And I have. So I need to change that to 0.3. Alright. So, conf t. And I want to go to that interface, and I want to change the IP address to 172.16.1.3.255.255.255.0, and we should do a copy run start to fix that, and router 4. What was it? Show IP EIGR Interior Gateway Routing Protocol interface. So we haven't formed an adjacency because this isn't exactly behaving normally, because we've treated this as an IP address, which is a bit of a problem, isn't it? Alright, let me just pause this for a sec. Okay, so I shot myself in the foot. Okay, D1 should be a switch port access, not a IP layer 3 address. Little bit of a mistake on my part. So, changed it back to a layer 2 switch port on VLAN 1. So router 1 is now connected to router 4. This is just acting as a switch for VLAN 1. And when we have done that and jump across to router 4, we now have an adjacency neighbor forming. And if we just repeat our interface command, we now have peers on each interface. All right. No, I'm not going to record this. It's not worth it. Own up to your mistakes. You do things live. I'm human, I make mistakes. So, all the devices now have routing. So if we do show IP route, we can see that we have Ds being injected into the routing table. So we have administrative distance of 90, and then we have various metric calculations for the various paths to those networks. So everything's working the way it should, except for the fact that we now have an issue where we have a little issue, not a major one, just a little one, where we're also active on interfaces that are facing devices. Okay, so router 1 is currently sending EIGRP hello packets down VLAN 2 because that's an active interface. So if we do IP, be right if I could type and talk at the same time, interface, we'll see here, if we expand this out, that it's going down VLAN 1 and VLAN 2. Now, we know VLAN 2 doesn't have any routers, so it doesn't need to be sharing routing packets. So to stop that, so that somebody can't impersonate a router and start influencing our routing information, is we make it a passive interface. So there's a couple of different ways we can do this, but which way are we going to do it? I think we'll just do it nice and easy. So if we go in the config T, go into router EIGRP 100, and we can say passive interface. What are we wanting to be passive? Well, we want gigabit 001.2 to be passive. This means hello packets will not be sent out of this interface. Now, I personally think this is probably the easiest way of doing it, because if you get the other way is to make them all passive by default and then open up the ones you want. So we'll do that on router 2, shall we? So again, config T and into the protocol we go, and we want to make this passive interface default DOM. So that is going to turn off the interfaces from participating. Now you wait long enough and you got the HIME expired, so our relationships with routers 1 and 3 have timed out. So now how do we fix that? Well, you specify that you don't want them to be passive interfaces, and you specify which ones you don't want to be passive. So horses for courses. If you want to start off with all your interfaces passive, use the default interface command, and you activate the interfaces that you want to run the protocol on. The network statement is to tell you which networks are to be advertised in the routing updates and which interfaces are going to be active in the routing process. That also includes the ones that are just there for the process of being advertised. They've got no active routers on that network, such as our little host VLAN down here. Alright, so that's the two versions there. As I said, I'll come back and do another lab video once I get my equipment that will run the named version of configuration. But this is the basis of it. So again, if we look at here, show IP protocols, we can see there that it's EIGRP 100. Here's our K values listed out. Maximum hop count is at default 100. Now we can change that to 255 if we need to. That's the maximum that we can take it up to. Maximum number of paths 4 for equal load balancing. And here's our networks that we're routing. Then we have our sources of information. So these are our neighbours, what their administration distance is, and when the last update was. So their sequence numbers. What else do we need to go through? Suppose we should go through the authentication process. I think that would be reasonable. Alright, so first thing to do in the authentication process is generate our keychain, which we need to be in global config first. So keychain, and we want to put the name of the keychain. So let's go EIGRP underscore key. And give it a key number. I'll use key 2. Then we'll give it the key string, and this is going to be our pre-shared key. So we'll be really authentic here. Alright, so next we go to the interface. So we want to put it on. If we have a look up here, 01 goes to 23, which is router 3. So there we go. So this is pointing towards router 3. And we want to put IP Authentication Keychain. And now we want to say the protocol that we're applying the keychain for, and then follow that up with the actual name of the keychain, which is EIGRP underscore key. Now you'll notice that the adjacency got toned down because the keychain has come into effect. So we want to continue our configuration, IP authentication mode, and we want to say it's the protocol and MD5. Now you do this on every interface that you want to have authentication running on. You can use the same key on multiple interfaces, but that's alright. So if we go to router 3, we'll see authentication failure message. Okay, key value mismatches, new adjacency, goodbye. Boom, boom, boom. So it's gone down and tried to come back up, but it's failed because we now have authentication required. So if we look here, router 3 facing router 2 is gigabit 000. So in the global config and interface G000, and we basically go through and do the authentication keychain EIGRP 100, and we will have a problem because we haven't generated the key yet on this machine, but we can type it in. Authentication mode EIGRP 100 MD5. Now if we go back a step, and we really should do the whole keychain EIGRP underscore key, and we'll say this is key 1, and what we're going to do, we're going to put a key string in, and we said Cisco 123. Why didn't it come up, you say? Well, the keys don't match, do they? So if I go to key 2 and put the key string in, Cisco 123, and show IP EIGRP interface. We haven't got it coming up yet. So if we have a little look-see protocol, and we really have to use the right command. Summarization. So nothing about authentication there. So if we do that detail command, show EIGRP interface. Another command that is not on packet tracer. That's interesting. All right, be like that. Okay, so EIGRP key 1, Cisco 1234. That really should be key 2. Because we look up there, this is key 2. So the keys need to be the same key. So config and keychain EIGRP underscore key. Okay, so new key 1, and then we'll make key 2, and we exited out of keychain, so up arrow, key 2, key string Cisco 123. And there we have our adjacency. So why did I deliberately put in the different key numbers? To highlight to you that they need to be configured the same at each end. So the keychain and the key. All right. So your key number is like your user account when you're doing authentication on PCs and that. When you go to log in, you put a username and then your password. So your key number is your username. So you're putting in a user and your password. That's what the key string is for authentication. They need to match before you get authentication to occur. Just in case you wanted to see that little bit of troubleshooting so you know what's there. Now, how can you do the next one, the variations? You just put the variants underneath it. Alright, so if we do router 1 and come up here again in the global config and go into our router EIGRP 100 and draw a question mark. Right down the bottom, variants, Okay, and then it'll be the number, the multiplier. So 2. Now it's got to redo its topology, its dual calculations to come up with the possible new routes that it can use and inject into the routing table. Now you'll see here we have 2 routes now for our 192.168.3 network. We have the original. You'll notice that it has a lower metric than the second one. That's how the variance works. Because they're not equal in the cost of getting to the destination, that path was not available before. Because only paths with equal cost would be injected under normal circumstances. When you change the variance value, you broaden the scope of the number of paths that are possible to be used that do not equal each other. Alright, I think that is enough for this video, especially as I'm starting to lose a little bit of the voice. And I'll catch you in the next one. Hope you have a great day. Thanks for watching, and bye for now.